Okay, so these are the other polar graphs that I want you to be familiar with. Okay, the first we're going to talk about, well, these are all called limacons. Limacons, they have this little cedilla underneath the C, making it a soft C. Limacons are formed by having this, well, plus, right? Plus and minus here in between, and a leading coefficient and a sum. So this is how you can tell we don't have a circle and we don't have a rose or flowers. It's because they have a plus in front of your trig. Okay, and it's these two numbers that are going to determine which trig we are going to be graphing, what limacon we're going to have, based upon your A value and your B value and how they relate to each other. Okay, so the first one we're looking at is something called an inner loop limacon, a limacon with an inner loop. Okay, and you know these are inner loops because, look at this equation, the B value here, the number in front of the trig word, is greater than the the sum number. Okay, that's how you know this is a limacon. If your B value is greater than your A. B is greater than A, we're going to have a limacon with an inner loop. So once you have identified it as being an inner loop limacon, it's how do we find out where the loops are? Well, the outer loop, you add your two numbers together, and the inner loop, you subtract your numbers. It's always B minus A. Notice the larger one minus the smaller one. We're not going to get any negative values around here. They're going to be these positive ones. Okay, so here is this example. Notice that we have 3 plus 5. 3 plus 5 is? 8, and that's the outer loop. 3 plus 5 is your outer loop. 3 plus 5, and then the inner loop, 5 minus 3 is 2, right? So that's why we have an outer loop and an inner loop. And there's one other thing that I need you to take notice of, and that is, where is your graph crossing your other axis? Okay? And that's at this number. This is the place where your graph crosses the other axis or the other pole. Okay? So we still have to talk about 4 things. These are the 4 things that I'm going to ask you about that you need to become familiar with. Okay? Number 1, what is the pole symmetry? Okay, what is the pole symmetry? That is the first thing. The answers are these. It's either the 0-degree pole or the 90-degree pole or the 180 or the 270. Right? These are the 4 poles that we can traditionally call the x and the y axis. Okay, but because it's a polar, these are polar axes. So 0 is of course the positive x-axis. Okay, here are your other ones. A 90 degree is your positive x-axis. A 180 is your negative x. 270 is your negative y-axis. Now, I just asked my class, how do we know which one it is? Okay, and you know based upon your trigonometry, whatever trig word is being used in your problem. So if we have a positive and a cosine, then that is the positive x-axis, which is the 0-degree pole. If we have a positive sine goes along with y, a positive sine is a 90-degree pole symmetry. Okay? Then where would we find a negative x? As a minus in front of the cosine, right? A negative. And then a 270 or your negative y would be if we had a minus with a sign. Okay, so depending on what trig word you have in your problem, you're going to have different types of symmetry. Okay, your 180 and your 0 come from your cosine, right? That's the horizontal or your x-axis. And the 90 and the 270 come from sine. Okay, that's important to know. So that's one of the things that I'm going to ask you is about pole symmetry. Okay? The other ones are about your loops. How far away is your outer loop, and how far away is your inner loop? Okay, I'm going to ask you those two things, right? So the answer is 8 is the outer loop, and 2 was your inner loop. And then the last thing I'm going to ask you is your non-pole intercept. Where does it cross your non-pole axis? Okay, so I need you to know these 4 things, these 4 attributes of each of our graphs. Okay, what is the pole symmetry? What is the length or distance of your outer loop? What is the length of your inner loop, right? How far away is that? And then what about your non-pole intercept? Okay, so those are the 4 things I'm going to ask about every one of these problems. So let's look at another one. So if the B value is greater than the A value, we have an inner loop limacon. Okay, that's how you know, all the time, every single day, including tomorrow. Now, what if we changed our A and our B to be equal? Okay, so what if A and B are equal? Well, then we have a new thing. We have an A and B are equal, then we have something called a cardioid. Okay, so you know it's a cardioid if A equals B. Both of your numbers in your equation are the same. Okay, a limacon with a dimple at the origin is what it's called. Technically, a dimple at the origin. Okay, but a dimple at the origin comes out to look like a heart, which is why they're called cardioids. Okay. So the pole, the inner one is at 0, so we don't have to worry, but the outer loop is still found by adding these 2 things together. Okay, so you know it's a cardioid because these numbers are the same. Okay, 3 plus 3 equals 6, which is why this is 1, 2, 3, 4, 5, 6 units away. Okay, it is a positive cosine, so it has a 0-degree pole symmetry. The positive x-axis, that's why it has its majority of its graph over here on the positive side of the x-axis. And then the last thing was your 3. So this will cross the y-axis at 3 units above and 3 units below your origin. Okay, so as a polar point, that's 3, 90, right? Because the positive y-axis is the 90-degree pole, and that's 3, 270, because the negative y-axis is the 270-degree pole. Okay, so these are the things that I am looking for on your graph when you graph them. So let's try one. This will be the first one that we've tried. 4 plus 4 sine of theta. So first of all, what is the pole symmetry? The pole symmetry is 90 degrees. 90 degrees. Okay, we have a positive sine. Sine goes along with the y-axis, so this graph should be mostly taking place up here in the positive y-axis part of your graph. Okay, so the outer loop is going to be 4 plus 4, which is 8. So we're going to put a dot here at 8. Okay, we're going to put a dot at 0 because, of course, 4 minus 4 equals 0. So we have a dimple at the origin. And then our other 2 points are 4. So what axis does it cross? If the 90 degree is our symmetry pole, it's going to cross the x-axis. 1, 2, 3, 4 to the right, and 1, 2, 3, 4 to the left. And that's based upon your A, right? The number not in front of your trig, but in front of the plus or minus sign. So those are the points that we are looking for. There's 4, 0 degrees, and this is 4, 180 degrees. So now you're going to try and make a circular circle with a dimple at the origin as best you possibly can. Okay, so I don't know if you want to make it very flat, you can make it deep. Just try and make it symmetrical-ish. Right, these are not exactly, beautiful to look at when you graph them. But I'm not going to grade your beautifulness. I'm going to grade your accuracy of the direction. Okay, so it's pointing up. If you graphed yours to the right, then that would not be correct. I'm going to grade how far away it is, right, the outer loop point. And I'm going to grade your intercepts. Where does it cross your non-polar axes? Okay, let's look at our friends that have an A value that's greater. Okay, so in all these problems, you'll notice that the A value is greater than the B value. Okay? So these ones are called limacons with a dimple not at the origin. So notice the origin here. The dimple is not at the origin. So we have 4 minus 3. Notice the A is greater than the B now. The A value is greater. Okay, which means we're not going to have a dimple at the origin because 4 minus 3, well, that equals 1, right? So this is 1 unit away from its pole of symmetry. So the pole of symmetry, let's look at that for a second. We have a negative and a cosine. So it's going to occur in the left side, right? So now we have a 180-degree pole symmetry. So that's where your outer loop, right? 4 plus 3, that's the outer loop, is 7. That's why we're here at 7. 1, 2, 3, 4, 5, 6, 7. 4 plus 3 equals 7. But 3 minus 4 is negative 1, which is why it's 1 unit on the opposite side of your origin. Okay, and we still have this as your non-polar, so 1, 2, 3, 4, and 1, 2, 3, 4. Those are where it crosses your non-pole axis, in other words, the y-axis. Okay, so the symmetry is the same basically for all polar equations. So let's look at ours here. 6 minus 4 sine. So first of all, let's talk about the pole of symmetry. We have a negative and we have a sine, which means the pole symmetry is going to be 270 degrees. Okay, negative sign means it's going to open down. So the outer loop, 6 plus 4 is 8. Not 6 plus 4 is 10. 10 is 6 plus 4. And then 4 minus 6 is negative 2. Okay, I guess we could do 4 plus 6 and just be consistent like we're supposed to be. 4 plus 6 is 10. And 4 minus 6 is negative 2. So we're going to be 10 units. There's 8, 9, 10. It's off of the grid, but we can deal with that. 10 is right there. And then negative 2 is 2 units on the opposite side of the origin. Okay, on the opposite side of the origin. That's what our negative means. A positive is in the direction of symmetry, and a negative is in the opposite direction. And then since we have an A value of 6, that means it's going to cross your x-axis, or your there is 6 and at the other 6. Okay, so these are the points that I'm going to be looking for on your graph. So there's going to be a dimple here at negative 2, right? So we're going to put a little dimple to tell ourselves that there's a dimple here. And then you're going to do your best to make it look semicircular as it goes through these points. Okay, just semi, it's not a circle, but it's not an oval either. Okay, so this is a limacon with a dimple not at the origin. Dimple not at origin. Okay, the A value is greater than the B value. We have a dimple, but the dimple is not at the origin. Okay, and then our last limacon is not having a dimple at all. And you can tell because the A value is more than double the B value. Okay? So if your A value is double or more, right? If A is more than or equal to 2 B's, greater than or equal to, then we have a no dimple limacon. So notice right here, it's flat. It does not come to a dimple. Okay, it's like you took an orange and you dropped it onto the floor, and now it is no longer round, but it has a flat mark on it. Okay, it's a non-dimple limacon. So let's look at 4 minus 2 cosine theta. Okay, 4 is more, I guess 4 is double, right? 4 equals 2 times 2. This is why we have a non-dimple limacon. Okay, so let's look at the pole symmetry. We have a negative and a cosine. So it's going to be a 180-degree pole symmetry, or the negative x-axis. Right? That's the first thing that we look at once we decide what type of a limacon it is. So our graph is going to be mostly on the left side of your y-axis. So for 2 plus 4 is 6. So the outer loop is going to be here at 6. 2 plus 4 is 6. 2 minus 4 is negative 2. So we're going to have a non-dimple 2 units to the right of the origin, right, on the opposite direction of your pole symmetry. So the 180 is our pole, so it goes towards the 0. And now it crosses your y-axis at 4 and 4. Okay, so we have 490 as one intercept, and we have 4270 as the other intercept. Okay, now put yourself a flat spot. Remind yourself that because this is a non-dimple, that we have a flat spot there at the -2 part. So once you draw the flat spots, you try and make it go through your intercepts, circle around to your outer loop, come back through your other intercept, and then end at your other flat spot. So make sure that there's no dimple, right? You don't have to make it exactly flat, but make sure it does not look like a dimple. Okay, so if your B value is less than double, right? So it's about how the A compares to the B. That's how we know whether we have a inner loop, a cardioid, a non-origin dimple, or a flat one. Okay, remember these are all called limacons, and they all have an A plus or minus B. All right, that's all. Have a swell day.